class lesson 3.3 part 2, rates of change and behavior of graphs. We'll begin with number 1, where we are given a graph of the function p of t, and they've asked us to identify the intervals on which the function appears to be decreasing. So working on the graph from left to right, let's take a look. Starting here, we notice the y values are getting smaller. See how moving from left to right, those y values are going down. I'm going to put a large dot there. So how do we describe that interval? And I'm going to go ahead and write decreasing here so that I don't give any other intervals. And as you can notice, that's negative infinity going all the way to 1. And we will use a union. You can also use a comma. And I like to use a bracket here. You can also use a parenthesis. Then, note what happens here. This is increasing from here to here. That's not what we want. But starting right here and going all the way to here, we are decreasing. So how would I describe that? Well, that would just be from 3 to 4. And those are the intervals that p of t is decreasing. Okay, remember, we use intervals of x to describe the behavior of y. So when y is decreasing, when y is increasing, when y is constant, we use intervals of x. Okay, let's give number 2 a try. This time they've given us a graph of the function p of t below, and they've asked what intervals is p of t increasing on. So let's work from left to right. And look, this is all decreasing. That's not what we want. Why don't we go ahead and just place some points where we change from increasing and decreasing? That might be easier. So, but now we've come across an area where we're increasing. And note that the y values continue to get larger on that interval. And what interval is that? From -1 going all the way to 1. So let's go ahead and write that down. Increasing on -1 to 1. Quite simple. And then, of course, you can see here decreasing. That's not what we wanted. Okay, let's take a look at number 3. This is the same graph given in your initial lesson video, but these are different questions. And basically what was happening is from time equals 0 to time equal 100 hours. So this event took 100 hours. We were filling up a pool with this many gallons of water. And the pool was filling up, and then probably the water was shut off, and then probably the water was being drained, and then the water was shut off during that time period. So that's sort of a description of what's going on with this swimming pool graph. So let's read this. The graph shows the relationship between the number of gallons g of t. So these y values are gallons of water. And this x-axis is hours. Over what period of time is the water level staying the same and not changing? And this should have been period of possible times because we have 2 of those. We have from, it looks like 25 to 50 hours, that water level stayed the same. It stayed at 3,000 gallons. But you can also see that between 75 and 100 hours, that water level also stayed the same and did not change. So that would be from hour 25 to 50, and we'll use a union, or you can use a comma, 75 to 100 hours. For how many total hours does the water level increase? So let's work from left to right. We are increasing from here, from 0 to 25 hours. Okay? And then, so I'm just going to write this from 0 to 25 hours. And then let's see if we have any other areas. This is constant, so that's a no. This is decreasing, so that's a no. And this is constant, so that's a no. So, for a total of 25 hours. That is how many hours the water level was increasing. Okay, let's take a look at our last question here. And this question says, how many gallons of water are in the pool after 60 hours? So really all you have to do is go to 60 hours and then maybe go across like this. And I would maybe give 2,500, but let's go ahead and just say 2,400. It's a little bit below. So I'm just going to put approximately, because both of those answers would be correct, 2,400 gallons of water. And that concludes your second part of class lesson for section 3.3.